Want to see something cool? Alexa, what's the weather outside in Denver?
Right now in Denver, Colorado, it's 31 degrees Fahrenheit with cloudy skies. Today's forecast has snow flurries, with a high of 35 degrees and a low of 16 degrees.
Okay, I know the Amazon Echo has been around for a few years, so this might not seem so interesting, but voice is still the new frontier in the world of computer interfaces, and it's all made possible with embedded machine learning. When we think of machine learning, we usually think of powerful servers crunching tons of data in order to do things like filter out spam emails, recommend movies for us to watch, and predict traffic patterns during our commute. But not all machine learning can be done in the cloud. Sometimes you have to compute things locally to get the job done, and this is the world of edge AI. For example, what happens if a self-driving car loses its internet connection? It needs to be self-reliant enough to obey traffic laws and not crash into anything. That means putting a lot of processing power in those vehicles in order to capture data from the various cameras and different sensors and then use it to make split-second driving decisions. For years, machine learning research has been focused on large servers and desktops, even though self-driving cars require powerful computers. Simple object detection in a picture requires thousands or millions of operations in a complicated neural network. Researchers in the last few years have made huge efficiency gains in being able to run machine learning algorithms on tiny microcontrollers. And there are some tasks that can be accomplished with smaller neural networks or simpler machine learning models. That leads us to embedded machine learning, or TinyML. Running machine learning tasks on a single board computer isn't really anything new, but doing them on a microcontroller opens up a new world of possibilities. Because microcontrollers are cheap and power efficient, we can begin to make a whole new generation of AI-powered electronics. This Echo is one great example. It uses embedded machine learning to listen for the Alexa keyword and then streams everything after that to a server, which then processes your request using more complicated machine learning algorithms. In this course, my fellow lecturers and I will introduce you to important machine learning concepts and how you can apply them to your embedded projects. We'll go over what is AI and machine learning, how to collect data, extract features from that data, train a machine learning model, and deploy that model to an embedded system. In this course, I'll show you how to create two different demo projects using your smartphone or an Arduino. The first is a gesture recognition device, and the second is a speech recognition system. You'll also be asked to modify these projects for your own use cases. We'll use a tool called Edge Impulse to help us curate data and train our machine learning models. I want this course to be an overview of how to build a machine learning system, so you can see the process in action rather than getting bogged down with the specifics of machine learning. There are many great books and courses out there if you want to dive deeper into machine learning. However, this course does not assume you have any prior machine learning knowledge. My hope is to get you working with and playing with embedded machine learning in only a few hours. I recommend having some experience with Arduino or the C programming language to get the most out of this course. Even though there are many build systems out there for microcontrollers, I plan to use Arduino for the demonstrations, as it's easy to set up and lots of people have experience with it. Feel free to take what you learn to your own development environment. I hope this course inspires you to build some amazing things with machine learning. Let's dive in.